Hi, my name is David Carvajal. This is going to be my demo for my part of Lab 1.
Hello, my name is Ashlee Rice-Bladykas, and today I'll be demoing Lab 1 for computer communication.
Hi, my name is Giovanna de Castro Pedro, and this is Lab 1 for computer communications.
I've created a slice already in the Jenny portal, completed being ready. So now I'm going to be able to open up, be the same login for all three.
So first we're going to look at the network topology. These will turn green in a second, but this was made using the EG 3 nodes mesh given in the lab instructions. As you can see, the 3 nodes are connected via 3 virtual links. You see it turned green there for just a second. But the details page here is going to show us the IP addresses, the login information used to access the nodes via the PuTTY terminal, and also the information for the links themselves. This is where I get all of the IP addresses and such. Here we have node 1, also known as node A. You see all the information used to log it in and its IP addresses. So this is the IP address for node B, the same one we used in that command earlier. See the logins here.
So here we're at the Genie portal and we can see all slices, and we'll click on the one from Lab 1. Here we can see all our 3 nodes, node A, node B, node C. These are the details from each one of our nodes, the connections A, B, and C. So what we're trying to implement in this lab is our 3 nodes, like in the slices, and we are going to try to reroute the route from node A to node C. Currently in this configuration, they are all connected together, A, B, and C to each other, but we want to reroute node A to node C through node B. So we are at node A, and what we want to do first is to test traceroute between node A and node C. Node C's IP address is 192.168.2.12, going from node A to node C. It will also tell us how fast this packet will get there at node C. In the traceroute command, we can see here that the packet is going from node A to node C as a direct link 1, and it's taking around around half a millisecond to get there. So what we're also gonna do is we're gonna ping 4 times to see how long it takes for these 4 trials of data to get from node A to node C. Also, to correctly identify the IP addresses from each node and each link, we can pull up the route command, and this will show us the kernel IP routing table. So we can use the route-n in the first one to see the IP addresses, and the route-e in the second one to see all the node names as well.
So as you can see, we can currently access node C from node A directly. However, we would like to change the routing topology of this network so we can use node B as a router or an extra quote-unquote hop in the network. This can be accomplished by defining a new route in the routing table of node A. We will define all of the routes to IP address 192.168.2.12, which is also known as node C, to use node B as a gateway, therefore completing the desired network topology. So I just type in the command to do this. So what this command does is just add that to the routing table. Okay, and that should do it. So what this is doing is essentially just saying that we're going to route all the traffic to this IP address here through this IP address, which corresponds to node B. So now we're going to check for network connectivity on our resource to our resource on node C. So I'm once again going to run a trace route.
If we are to now try to run the traceroute command to our original address of the 2.12, we'll see that it takes 2 hops to get to that location. The first going from A to node B, the link that we set up, and then from node B to node C using the other link. So now we see that data should be transferred from A to B to C, and we can check on that by pinging once again times. Actually, should be the same as this. And we see that no packets are lost, 5 were transmitted, so it's correctly getting to the destination, but we see that the time that it takes to do that is now almost double, so significantly higher than it was before, and that's because of the intermediate stop of getting from A to C now. So that concludes my demo, that we've currently set up a new route to go from to forward packets from A through B to C. And that also represents this diagram. Thank you.
And that is lab 1. Thank you.
And that concludes lab 1. Thank you.